Let's look at converting the polar equation to rectangular form. The other day we looked at converting coordinates, either rectangular form to polar or polar to rectangular. But we're going to actually use the same things that we used the other day to convert the equation forms. Remember, there are four things we want to use when we are doing these conversions. The first is Pythagorean theorem. And it's really helpful if you'll write these down when you're working on conversions. We know that sine of theta is y over r, cosine of theta, x over r, and tangent of theta is y over x. If we are going to convert polar to rectangular, we want to get rid of r and theta, and we want an x and a y, or just an x or just a y. But we definitely want to eliminate the r and the theta in the problem. There's a couple ways I can do this, but I'm going to start out using the fact that I know sine of theta is y over r. That gives me r equals negative 4y over r. I'm going to multiply both sides by r to get rid of the fraction, which is r squared equals negative 4y. R squared is x squared plus y squared, so I'm using this fact over here. So I'm going to replace r squared with x squared plus y squared. And I'm done, guys. To switch polar to rectangular, you have to eliminate the r and the theta and get an x and a y, or a version of an x and a y, and I've done that. Let's look at B. It says theta equals 3 pi over 4. The r parameter is not here. What I want to do now is, I guess I could actually just pick my favorite trig function. One thing I do want to consider, if I choose sine, then that's going to put the r back in here. If I choose cosine, that's going to put the r back in here. Tangent doesn't have a r value in it. It has a y and an x, which I'm actually trying to get to. So I'm going to use tangent. I'm going to tangent the left side, which is fine as long as I tangent the right side. And using the fact that tangent theta is y over x, I'm going to replace tangent theta with y over x. The tangent of 3 pi over 4 is actually negative 1, using the unit circle. Y over x is negative 1, and then I'm just going to multiply x on both sides, and y is equal to negative x. Let's look at C. You know what? I think I'm going to leave C for you, because what I just did is kind of a big hint. You already know what tangent theta is. Use the fact that tangent theta is y over x. Let me go to E. So E is r equals 4 sine of theta. And this is going to be really similar to the one before. I know in A, I know that sine of theta is y over r. R is equal to 4y over r. Multiply r on both sides. R squared equals 4y. And then I'm going to use the Pythagorean theorem that r squared is equal to x squared plus y squared. And that equals 4y. So really similar to A. And I want you to go back and do D and C after we're done with the video. Number 2, convert the rectangular equation to polar. I'm basically going to be using the same 4 theorems, but I'm going to use another version of not the Pythagorean theorem, but the trig values. I'm going to use the fact that sine theta is y over r, cosine theta is x over r, and tan theta is y over x. But in this, I may actually use the fact that if I use a little algebra on this, that y is equal to r sine theta. And if I use a little algebra on the cosine, I know that x is equal to r cosine of theta. All right, so we have x equals y squared. Remember, rectangular is an x and a y. Polar is a r, a theta, or both. I can see that x is r cosine of theta. I'm going to replace the x with r cosine of theta. And then I'm going to replace the y with r sine of theta. The y is being squared in this equation, so I'll have to put the square there. So r cosine of theta is equal to r squared sine squared theta. And for now, that's good enough. I just want us to be able to convert to an r and a theta. B, if we take a look at B, x squared plus y squared. I know that x squared plus y squared can be replaced with r squared. R squared would be 4. If you square root both sides, r is equal to 2. And that would be it because I got rid of the x and the y. I'm going to let you try C on your own. 3, sketch the graph of a polar equation. Change the mode in your calculator to polar. All right. Now, I do not have a graphing calculator on the computer. I could use Desmos, but I'm going to actually walk you through what you do in your graphing calculator, the TI-84. So you're going to want to go to mode, and you're going to want to switch the mode to polar. When you switch the mode to polar, you're going to go to y equals, and what you're going to see when you go to y equals, the y is not going to be there. What you're going to see is r equals. In this scenario, you're going to type r as 4. There are different ways to adjust the window. What I usually do is I hit zoom 6 and see what that looks like, and then if I need to, I hit zoom fit. So I'm going to actually type it in my calculator now. And I didn't tell you radian or degree. I think I'm going to convert to, I'll type this in degree and see how it looks. Be very careful. Sometimes your calculator is misleading. If you look closely, it actually goes through 40, negative 40, and then if you count on the y-axis, it's up 4 and down 4. My calculator is actually looking like an ellipse, when in actuality, this is a circle because the center would be 0, 0, and the radius is 4. Okay. So sometimes your calculator, because it is wider horizontally than it is up and down, it will take a circle and it will look like an ellipse. All right, so we're going to try this one. I actually want you to find a correlation between if the angle is double, or let me put it a different way. If the angle is like an even angle, and an even angle would mean 2 theta, 4 theta, 6 theta, and if the angle is an odd, 3 theta, 5 theta, 7 theta. Again, I want you to type this in. Make sure your mode is in polar, and you all can help each other out with this. If you type 3 cosine of 2 theta, you're going to see what we call a rose curve. It almost looks like a four-leaf clover, and it's going to kind of look like this. And this clover is said to have 4 petals. So I want you to try this one and see how many petals it has. Now, the length of the petal should be 3 because we've got 3 in front of the cosign, and it shouldn't matter which petal you're on, whether you're on um, the one going vertically or either the ones horizontally. The petal in C should be a length of 4 from the origin. But I want you to just play around and explore a little bit. What if you put in 3 cosine 4 theta? How many petals would you have? If you put in 4 cosine 5 theta, how many petals would you have? Again, this is called a rose curve. Polar coordinates make different kinds of curve, and this one is called a rose curve. At the end of the video, after you finish this, if you've got any questions, please type them in the Canvas page, and we will look at them when I get back.